Welcome back to Learn SKN, and today we're continuing to look at the May-June 2019 Economics, CSEC Economics Paper 2. And so we completed questions 1 and 2 in two previous videos, and so we're going to be looking at question 3 in this video. So question 3 for the May-June 2019 Economics Paper 2 for CSEC. Alright, so let's just jump into that. Number 3, Part 1. Define the term demand curve. So what is a demand curve? For 2 marks. So a demand curve is simply the graphical representation. A demand curve is a graphical representation of the quantities demanded of a good by a consumer at each price. So it's a graphical representation of the quantities demanded of a good by a consumer at each price. That is a demand curve. That's the definition of a demand curve. It's a graphical representation of the quantities demanded of a good by a consumer at each price point. Then part 2, list 4 factors that may cause a shift in the demand curve. A shift in the demand curve now. 4 factors. What can cause the demand curve to move either left or right? Fully left or right. Not a movement. Price causes a movement. We're talking about a full-on shift. So that's left or right, increase or decrease. And for that one, we know, so those are basically the determinants of demand. They are the ones that would cause a whole shift. Now a price would cause, I would say, a movement, all right? But for a shift, we're looking at things like change in the population, increases in the population cause demand to increase, decrease in the population cause demand to decrease. So if the population goes up, the curve shifts to the right. Population goes down, curve shifts to the left. Change in income. You make more money, you demand more. You make less money, you get a cut in pay, you demand less, so therefore the curve shift to the left. So you make more money, you get a promotion, shift to the right. You make less money, demotion, shift to the left. Tastes and fashions. So if all of a sudden you don't like ripped jeans, then the demand for ripped jeans go to the left, the shift go to the left. But if you fall in love with ripped jeans again, then the demand for that shifts to the right because it taste and fashion. Seasonal factor. Seasons and times of the year will cause demand to change. So, for example, Christmas time, you might demand more. Easter time, you might demand more saltfish based on where you're at. You might demand more Easter buns if you're in Jamaica. So, demand for Easter buns shift to the right. Then, when you're coming out to Christmas, then you demand certain things, so the demand for that goes to the left or right, regarded. And then you have the price of other goods. The price of other goods. If there's an increase in the price of butter, the demand for margarine will rise. Okay, so if there's a price increase in butter, because margarine and butter are so similar, good substitutes, then if the price of one increase, then the demand for the other will increase. So there's a shift to the right for that one, a shift to the left for the other one. So those are what the determinants of demand. They are what would cause the shift in the demand curve, whether it is left or right. So that's 4 easy marks right there. They actually just list, right? Just list. Then we have part 3, or B of question 3B. Assume there is a 20% increase in the price of medicine and a 20% increase in the price of soda. So 3 marks. Discuss whether the percentage change in quantity demanded will be greater for medicine or for soda. Okay, so this one is a very, I love these kind of questions, these application questions. You have to know what you're talking about to apply it. So let's look at this now. We're looking at elasticity right now, right? We're looking at elasticity. And so we're saying here, assume there's a 20% increase in the price of medicine and a 20% increase in the price of soda. Now from these two, one of them, there are ton loads of substitutes. For the other one, not so much. The classic example we give is insulin. That's a medicine. And there are not many substitutes out there for insulin. So the price for insulin goes up, then the demand wouldn't really change that much because that would be inelastic demand. What else you going to buy? There's no substitute out there. But sodas now, I mean, if the price for one go up, then you got Pepsi, you got Coke, you got Dr. Pepper, you got Buster, you got a whole lot of them in the Caribbean. So you got a lot of soda options out there. So they're saying here, if the 20% increase in the price of soda, I mean, you're gonna shift to something else. right? So the quantity demanded will be greater for medicine or soda. So the quantity demanded would be, well, it's going to be basically the same for medicine in a sense, because there's no close substitute. So we discuss whether the percentage change in quantity demanded will be greater for medicine or soda. So of course it's going to be greater for soda, because the sodas are elastic. The normal goods are elastic. The price of one go up, you go to the next one, you shift to the next substitute, and the next substitute. But for medicine, there are no close substitutes, and so therefore the percentage change in quantity demanded will be less. It would not be greater than in this soda. The medicine would be less if you move at all, because you must use that kind of medicine. Alright? So we've got elasticity here. Sodas are elastic, medicine inelastic, little substitutes. Sodas elastic, many substitutes, and so the percentage change would be greater in medicine, in soda, if the price goes up. So number 3, B, part 2. Before the change in price of soda, 300 bottles of soda were sold per week. That was the original demand. 300 bottles were the original demand for that, right? And then what they're saying here now is that after the 20% price increase, only 150 bottles of sodas were sold per week. So calculate the price elasticity of sodas. And so if we jump here in the textbook, we see the formula for price elasticity, which is percentage change in quantity demanded over percentage change in price. Now you have to break it down now. You have to find the percentage change in quantity demanded, QD, and then you have to find the percentage change in price. And so we come down here. To find the percentage change in quantity demanded, what you need is the new quantity demanded minus the original quantity demanded. That's the change. So remember, the new one is 150 and the original was 300. So the new one is 150, original was 300. So minus that, to get 150, which is clear. We don't even have to go through the math because it's half. It's clear. It's 150, right? 150 plus 150 is 300. So we don't have to go through the math for that one. What we have to go through the math for now is the percentage change in quantity demanded. So what you do, you take the change in the quantity demanded, which is 150, and you put that over the original quantity demanded, which is 300. So the change 150 over the original, do that math, you divide it, and you would get your 50%. Let's do that math quickly. So it's 150 divided by 300 times 100 over 1 equal 50%. Right, so that's 50%. So we found that already. So we have found the quantity demanded, the change in quantity demanded, which is 50%. Now the percentage change in price is given. It's in the question. It's 20%. Right? So the percentage change is 20%. So we already have that. So we have to do now, we have to take what we just found. We have to take the percentage change in quantity demanded. So we have the percentage change in quantity demanded, which is the 50%, and the percentage change in price, which is given as 20, and you have to work the maths, and you get that. So it's 50 divided by 20 equal 2.5%. So 2.5% is the coefficient, right? And so because it's 2.5 and it's larger than 1, a lot larger than 1, we know that the soda is very elastic. And so that's the elasticity of the soda. For every percentage change in price, then there's a change in demand of 2.5%. We got that. Alright, so that's the answer for that one. Moving on to the next one. Explain how each of the following changes affect the equilibrium price and quantity of cars. So how each of the following changes affect the equilibrium price and the equilibrium quantity of cars. And we have the price of public transportation decreases, and then we have the price of gasoline decreases, and at the same time the number of companies selling cars also decreases. So you have to answer those two, 4 marks each. So let's say explain how each. Okay, good. So let's go. So we're looking at the price of public transportation decreasing, meaning it's cheaper now. And so how would that affect the equilibrium price and quantity demanded of cars. Now, for sure, we know the equilibrium price is going to fall, because if public transportation decreases, we're talking about ceteris paribus here, all things remaining equal. So all things remaining equal, if the price of public transportation decreases, then the demand for that should go up, and the demand for cars should come down, and the quantity demanded for cars should also come down, because the demand for cars has gone down. The equilibrium price should fall, and so that's what we have to see here, right? So that's how we explain that one. So explain how each of the following changes affect the equilibrium price. So again, because the price of public transportation has fallen, then that means now that more persons are going to be demanding public transportation because it's cheaper than the cars. And so if more persons demanded public transportation, then that means there's a fall in the demand for cars. And so if there's a fall in demand for cars, ceteris paribus, then that means that the equilibrium price for cars will fall, and the equilibrium quantity demanded for cars will fall, because there's a decrease in the demand for cars. And so if we jump to our textbook here, we have the outline the effects on equilibrium price and quantity of a shift in demand or supply. So if there is a decrease in demand, a shift to the left of the demand curve, then equilibrium price will fall, as I said, and equilibrium quantity would also fall, right? So that's clear. There's a decrease in demand for cars because the price of public transportation gone down, so it's more favorable. Demand increase for that one, and so that's how we explain that one. All right, and then now if we jump to the second one now, the price of gasoline decreases, and at the same time, the number of companies selling cars also decreases. So now this is just not a ceteris paribus situation now. We're talking about simultaneous things happening. And so this one is quite tricky now. Now let's look at it carefully. Let's break it down. So the price of gasoline decreases. What does that mean? So the price of gasoline decreases, that would mean that driving a car becomes cheaper. And if driving a car becomes cheaper, then the demand for cars tend to go up, because you have your complementary products. Now, if something complements something, if the price of one of the complements changes to whatever, up or down, that would affect the actual product. So the gasoline and the car, they are complementary products. So if the price of gasoline goes up, then the demand for cars would go down. Because if gasoline comes too expensive, then persons can basically pack up their cars, catch a taxi, catch a maxi, catch a bus, whatever, because it might be cheaper for them. But if the gasoline price goes down, then it's cheaper to operate your car, and so you might want to demand the use of your car more. You might want to buy it, so the demand for cars would go up. And if the demand for something goes up, what happens to equilibrium price? Right? Back to our table. So a shift in the demand. So if increase in demand would cause an increase in the equilibrium price, and also an increase in equilibrium quantity. So if you look at this one right here, how an increase in demand affects equilibrium. So you have demand started at D1, then it increased, so it shift to D2, and so you see the price move from $2 to $2.50 right there. See that? Right there. So you can see that. But what's happening here now? There's a next thing now. The question also affects, talk about supply now. But now you see that the number of companies selling cars also decreases. Now when that happens, when the supply falls, then the equilibrium price goes up, right? And so, but the thing here now is that this might be a little technical. I don't know if CSEC meant for it to be this technical, but at this point, we cannot really determine the equilibrium quantity. We cannot. We know that the price going up, but what quantity goes to what price point? We cannot really see the match, because right now people bet it's being bid up, the price is being bid up, and we don't know the final outcome based on just the information we're given here. So we can't really tell, because the price gone up for sure, because demand gone up, supply gone down, price gone up, but we can't really tell the quantity, equilibrium quantity at this point. So for this one, we know that the price gone up because of more demand, less supply, but we don't know what happened to the quantity, equilibrium quantity, because at every new point, there's a higher price. You're demanding a higher price for cars at every different point, equilibrium price. But we don't know what quantity matches those prices, because right now it's a bidding war. Everybody want these things, so we don't know what's going on here. All right, so that's the outcome for this tricky question right there. I realize I gave you a lot of line to explain all that for your full marks. All right, so that's it now for question 3 for the May-June 2019 CSEC Econ paper 2. So if you want to know when you do paper number 4, question 4, of course you have to like the video, subscribe to the channel, and hit the notification bell. All right, so thanks for watching, thanks for listening.